Hi, and welcome to the second lesson. This is a lesson on computers and binary. As a part of the last lesson, we had a look at what computer hardware is and on the different components that make up computer hardware. As a part of this lesson, our objective is to understand how computer hardware works internally. This is followed by an understanding of what a computer program is and what programming languages are. Finally, towards the end, we will discuss the use of tools such as compilers and interpreters. Let us get started. Internally, a computer is made up of many number of tiny parts called transistors. A transistor is an electrical switch which gets activated by the signal it receives. If it receives a signal, it gets to the on state. If there is no signal, it remains in the off state. Thus, a switch can exist in one of the two states, an on or an off. If there is a single switch, it can be used to represent either an on-off or a 1-0. This 0 or 1 is called a bit and is the smallest amount of information a computer can store. To represent these two values, the binary system is used. The number system that we use regularly, namely the decimal number system, is composed of values from 0 to 9. Similarly, the binary system is composed of just two values, 0 and 1. And the computer hardware uses this binary system. Any type of data, be it text, an image, audio, or a video, or any instruction that we give to the computer, is ultimately represented in the binary form as a set of zeros and ones. For example, hello is represented in binary form as this. Let us have a look at how decimal numbers are represented in binary. Here we have used 3 bits to represent a decimal number. 0 is represented as 000 and 1 as 001. This goes on and 7 is displayed as 111. Any instruction that we give to the computer is also converted to binary and executed. Let us have a look at an example to add numbers 4 and 3 and see how it happens in binary. 4 is represented in binary as 100. 3 is represented as 011. Let us try to add them up, beginning from the right. 0 and 1 adds to 1. 0 and 1 adds to 1 again. 1 and 0 adds to 1 as well. Thus, the result is 111. This is the binary equivalent of the decimal number 7. This is how data and any instruction is converted to binary. Let us proceed to understand what a computer program is. A computer program is a set of instructions given to a computer to perform any task. But as we just saw, computer hardware operates in binary, but binary is very difficult for humans to work with and is very complicated for us to understand. Thus, programming languages were introduced. A programming languages help the user to give instructions in a language that they are comfortable with. Examples of programming languages include COBOL, C, C++, Java, Python, JavaScript, Ruby, etc. Thus, programming languages enable humans to write code in a language that they are comfortable with. But computer hardware understands and operates only in binary, that is, with zeros and ones. So, how does the translation from the programming language to the binary form happen? Tools are available that help to translate the programming language to a form which is understood by the computer hardware. The code that is written in a programming language is also called as the source code. Tools are used, namely compilers and interpreters. If you look at the diagram here, there is a high-level language code which is written in a programming language understood by humans, This code, when given to a tool called compiler, gets converted into the binary form which is understood by the computer hardware. The computer hardware can make sense of the code and can execute it. Hence, this code is also called as the executable code. Compilers and interpreters are thus used to translate the instructions given by the programmer in a programming language to binary form which is suitable for the computer to work with. There are a few languages that use compilers and a few others that use interpreters. Compilers and interpreters differ in the way they translate instructions to binary. Examples of purely compiled languages include C, C++, and Go. That is, languages which use only compilers to translate to binary form. And examples of interpreted languages include PHP, Ruby, and Python. The difference between compilers and interpreters is beyond the scope of this lesson. We have reached the end of the lesson. To summarize, we had a look at how computer hardware works internally. This was followed by an understanding of what a program is and what programming languages are. Finally, we understood the need for tools such as compilers and interpreters. As a part of the next lesson, we will have a look at the process of writing a program and executing it. Thank you.